So now what we need to do is, let's again redetermine those components of or what we're looking for is all components of the x prime y prime system of all points that lie in there. So recall, let's look at B right there. B has an x component and a y component in the xy system. B also has components in the x prime y prime system. Now here's theta. That's just geometry. It's going to allow you to know that those are the same angles. So you can capture that. Now what I'm going to do here is I'm going to start drawing some triangles so we can get an understanding, so we can figure out what the relationship is between these two. So if I drew this triangle down here, you can see this is my x my x component of point B in the x prime or the xy system. Now just by, if I know the hypotenuse of that triangle, I know my angle, I can then figure out what the other two lengths of my triangle are. Let's take a look at this triangle now. Again, the hypotenuse right here is y of B, meaning it's the y component of B in the xy system. So based upon knowing the hypotenuse of that triangle, I can also figure out then the other components of that side of the triangle. Now remember what we're solving for and what it is we're looking for. We're looking for x prime of B. We don't know that value yet. We started in the xy system with known coordinates, and we're looking for the x and y components of these points in the x prime y prime system. So x of B I knew, y of B I knew. Don't know, and don't know. So you can see what we're looking for now, alright? So I'm sure you can kind of start capturing a little bit of the idea of what it is we're looking for. So in reality, the length we're looking for is this one. And then we're also looking for this one right there. So to do so, what it is we're looking for is this. What it is we're looking for to be able to solve for that. So if this is the one that we're looking for first, let's see what we can figure out here. So x prime of B is what we're looking for. And this is the length that I'm looking for. That's what it references right there. So how can we get that? Well, if we know this overall length right here, which is x of B, so x in the xy system of point B times the cosine of theta, right? And we calculated then this length right here, which is the same as this one down here. Well, then you can just take that and take xb cosine theta, subtract yb sine theta, which will give you then x prime of B. So that all was just looking at the triangles and being able to figure out what that is. So now let's do the same thing for y. I told you we're looking for this length right here, from here all the way down to here. Well, I have two components that we solve for. I have this component, and I also have this component. So to get the overall length, and again you can see that to get the x prime and the y prime components, the components that we're using are in reference to the xy system, not the x prime y prime. That's the only way you can do it, because remember we're going from the xy to the x prime y prime system. So in that case, y prime of B is then going to be equal to x of B sine theta plus y of B cosine theta. So to determine the x and y components of any other system between these two, so this is just the x and the y system and the x prime y system, here is now your formula. Okay, all I did was take what we solved for up here and put it in a more general term. X of P is just some random point P. Scale now, I put the scale in there because we're going to be dealing with distances. For the most part, right now you and I will deal with scales equal to 1, so we're not going to be dealing with that per se very much, but that's where you place the scale. So nothing changed here, it's just I'm using some random point P, any point P. I should say P right there. And then Y, same thing, just by plugging in what we solved for here. So this is now the relationship between those two coordinate systems. That means any coordinate that I know have a known coordinate value in the XY system, I can now convert that into coordinate values in the X prime, Y prime system. The last thing we want to take a look at is an actual translation. So now that we've gone from XY to the X prime, Y prime, now we're going to a northing and an easting system. So once I've done my rotation, remember we talked about northing, easting, that's always referenced where north is always north. So we know the orientation of the axes. So what we did was we rotate our XY system to the X prime, Y prime, which is also parallel to those axes, to allow us to then do our final translation over to the northing and the easting system. So you can see here my difference to be able to get from this origin to this origin. It's just a translation, it's just a shift. You just take the axes and move the axes. And recall again, like I said, A, B, C, and D are not moving. So if I want to figure out any component on my easting, right, then I have a translation in X. I need to adjust it by this amount right here. And if I have any point I want to know in my northing value, I'm not dealing with a rotation or scale now. I'm just simply a translation. I have this amount of translation right here. So to be able to do so, we use coordinates of, a lot of times we don't know what this translation is. So if you don't know the translation, if you don't know the difference between the two origins that you're moving it around to, typically you can figure that out. But in this instance here, how you can do it and solve for. If I gave you the equation previous, where the easting component was equal to X minus X prime. So let's go back. I'm going like right here, and this is what we're looking for. Okay, so if we're solving for the translation of X, actually, yeah, we'll continue on right here. So if we're solving for that, let me go back one, sorry. We have something right here. We're solving for translation of an X. That's going to just be the easting coordinate minus X prime coordinate, which we showed right here. So that's what we're showing right there. So to find out what that translation is, we need to know what a point value is in the easting system, as well as the X prime system, to be able to figure out what that translation actually is. So you use a control point, which is known in both systems, or all three systems, to be able to figure that out. Alright, so now as we sit right here, for the overall coordinate transformation. So now we started with A, B, C, and D did not move. We calculated a rotation point, and we ended up with a translation between there. So we went from the green to the red, and then from the red to the blue system. So last thing we said was to get through the northing and the easting system, we took the X prime, Y prime system, and we just added on a translation. If you recall, X prime and Y prime, we said of any point, this is what it was equal to. And it was in reference to your original X and Y system. Here's the X, and here's the Y. Not the X prime, Y prime. Here's the only equation we have that's referenced to the X prime system. All I'm doing is just going back and solving for it. So what we're saying is we began here in the XY, and we want to end in the northing and easting, which means the X prime, Y prime is just an intermediate coordinate system. That's all that was. Because in the end we were looking for a whole transformation, including translation. So now last thing you do then is you take then your easting and your northing for any random point, plug in the values that you have for X prime, Y prime, what we solved for in these two equations, just going right here, plug those in, and then here's your random, here's your translations you have at the end. And so here now is your final equation to make any 2D conformal coordinate transformation.